Uh, Hello everyone. I think I'm Vietnamese, but I feel like we still have some English speaker here, so it's better to speak in English. So I will start with English, but it's okay, right? Okay, just start. Thank you everyone to attending here. I know this is last session, so everyone feel tired, but yeah, let's just start. And I'm be sure that this is just not full of information, but just really lightweight and kind of showing things. Okay, so let's just start. I'm Khanh. I'm a software engineer, a cyber agent, and I'm the maintainer of the PipeCD projects. And I do GitHub and Twitter. And my talk is about PipeCD, but before we get started, I just had a little bit share about the challenge of the deployment on multi-cluster and multi-cloud environments. So I'm listing here is some problem we face when we do the CI/CDs for the company-wide. I'm from the CI/CD platform team, and the first one I get here is different cloud, different tools. What I mean cloud here is, say for instance, is Kubernetes, AWS, GCP. For AWS, maybe it's Lambda, ECS, or something. Anything we containerized. For GCP, we have Cloud Runs, things like that. And if you have experience of working on some kind of environment that mixing in between many things like that, or maybe it's not just your team, but for your whole organization, different teams have different way to choose the platform, then you definitely face with problem like this. And the point is, for Kubernetes, we have some kind of community standard like Argo CD or Flux CD. But for the other, what do we have? We do not have any standard like that. And the next one is about the securities and observability. I know that most of people, most of company and most of team do use CI for CDs, which means that we have to share credential to the CIs. What we actually believe is we should separate the CI with the CD. The CI should focus only on the testing and building the artifacts, and the CD should be the one who take the rest from the artifacts to the cluster deploying. So it could be lead to some serious security issues if we mess up. Actually use one for everything. That why I played it as a second point. And the third is, how do we do progressive deliveries to multi-clouds? For here, I have a new word. Not actually new, but pretty new if you do not actually work as an CI/CD engineer, which is progressive deliveries. We know about the GitOff. We know about the continuous deliveries, which is CD, but for the PD, progressive deliveries, is kind of term of using some strategies to deploy your application. If you hear about the canaries, you hear about the blue-green release, that is talking about progressive deliveries. You not actually fully deploy your application at once. You have canaries version, you test it with your user, and if everything is okay, then you go next, release everything. Or if you get any problem, you roll back automatically. That kind of simple imagine about the progressive deliveries. So what do we have as a solution for everything? I'm not sure you guys have the same imagine with me, but the first thing that come to my mind if I have to do support multi-application kind, multi-cloud, is the Jenkins. I know it's still the standard for the for the community and for the markets, because I actually did that. I enjoy some conference in China and in America as well, and I asked this question: what do you use as the CD for your application for the system? And the point is, I am having here is Jenkins and other, which is actually the CI do the CD works. So basically, the half of the answer is CI do CD things, and the other half is we have everything on the Kubernetes that were pretty nice. So we use everything on Kubernetes, and we have Argo or FOSSASIA for that. And just a little bit mentioned here is the Argo really strong compared to the FOSSASIA. And so what is the problem? If the CD does the CI job, then it can lead to some kind of serious security issues. For Jenkins, you may hear a lot from the community, which is the performance issues. Basically, the Jenkins does not exist from the time when the cloud natives grow this much, so it's kind of understandable. And on the opposite side, we only have standard CD for the Kubernetes, so we have to do, for the other kind of application, like I just said before, serverless thing like Lambda, Cloud Runs, or Terraform, something like that. It says you have to has ton of script that running on Jenkins or some CI like GitHub Action, and it's costly to maintain that much of script cross different cloud and different application kind. So it is the gap of the markets, and we think that and we feel that. Not just feel, but we have experience on maintaining that kind of complex CI/CD for the whole company-wise. After this, I will share you a little bit more about that later. But we start this PipeCD projects as team projects, and the vision of the PipeCD is the one CD for all. And we want to mention here is we are CD. We focusing on only on the CD. CI probably we can use just compact CIs or open on earlier pipelines, just as previous one. But for the CD, we want to make this PipeCD as the one CD for all. It's designed to overcome the challenge across our experience of various application to various kind of platform and different cloud, and it has to be work easily and smoothly across the scalable organization. And a little bit of information to share about the PipeCD. It's the GitOps style CD tool, and it takes multiple app and multiple provider as the first citizen, and it's work well with it's fit for the larger scale organization, but it's work well with a single project as well. And its currently status is the CNCF sandbox projects. If you not know about the CNCF, it's a Linux Foundation sub foundation, and it's fully open source. Currently, we passed 3,700 commit already, and we have about nearly 80 contributor worldwide, and we're on the way to get our first 1,000 stars. So if you like, please support us. And interesting thing here is there is a bot in the contributor list, and also we have some former PTIT student as the contributor currently as well. They know me, and I invited them to be the contributors. Leslie. Next could be the PipeCD at a glance. I will guide you some feature of PipeCD and some retrospective of the projects. First, as I said before, PipeCD is support the range of application. We currently support the Kubernetes the AWS ECS Lambda, the GCP Cloud Run, and the Terraform. And this is the what can I say? The simple of what you need to actually use the PipeCD in action. We have here is the Kubernetes application manifest. We have deployment, we have service, and the smallest setup, and we need to prepare PipeCD configuration YAML, and it's kind of thing like this. Basically, it's define the pipeline of what actually it going, and a pipeline is set of state that we predefine but customizable for application guide, and we have some kind of common state as well. You can actually mix it with the application guys, so build up your pipeline, and this is what you get with this kind of pipelines. And the nice point is it's work not just for Kubernetes but the other application platform as well. And this is a sample for the cloud runs. We see here is the same things. We have service.yaml, which is the setup manifest for the GCP Cloud Run, and we have the pipeline definition YAML, and we get this one pretty same. And next retrospective is PipeCD integrates with the Kubernetes ecosystem easily. The PipeCD work well with customized ham on Istio, if you know whatever from here. And next thing I'm showing you here is the simple UI for the deployment details of PipeCD. We have here is the pipeline I just showed you before. It's combined of 4 different states, and we have state log and clicking allow right here. This one is application detail based, where I want to talk a little bit about this one. This one is drift detection feature of PipeCD. It's compare the manifest and the in cluster state, and if it find any different, it's showing here, and you can trigger the recycle of your application from here. Basically, PipeCD work. We have 4 kind of trigger, which is on git chain, on diff detection, on manual click, or on chains. I will talk about on-chain trigger later. Next is the overview of the PipeCD architecture. This is the reason why PipeCD, I said, is work well with the large-scale organization, as well as working well with the simple project as well. We see here that PipeCD combine from 2 components, one centralized control planes, and many PipeCD, we call it an agent. So in a simple case, the platform team, I mean the whole companies only need to have one centralized control planes, and basically the CI/CD team or the platform team will operating this control plane, and it's a stateful component, while the agent is stateless component. Every product team, developer team can install it inside their cluster, and it's just a single binary anywhere. And we test it running as a Kubernetes pod, or just in the VM as a process, or as a serverless handler. Anything, it just work well. And when we talk about scale, we have one centralized control plane that actually the platform team need to care about. Why the company-wide scaling? We have new team, we have new project, we have new cluster, just install that agent to that cluster, that all. And everything working well, at least in our case. And if you are platform engineer team who maintain the CI/CD for the whole companies, your job is install the control plane and operating is. I can say that it's much less work compared to my previous experience when I have to maintain the whole Jenkins thing, also with the Argos updating. If you use Kubernetes and you algo, when you update your Kubernetes cluster, you have to ensure that the algo is still working on that. Or vice versa, when you update algo, you have to ensure that your current Kubernetes cluster is still working. Something like that. For PipeCD, platform team has to maintain the control plane only, and it's basically a Kubernetes application, but it's well containerized, so you can actually install each component as well. But it's recommended to just using ham install command, and everything will go up. And it's even easier when you look closely. We have 5 components inside the control plane, but this tool is the cloud provide managed service, which is say this one can be RDS, RDS, or Cloud SQL from GCP, Aurora from AWS, whatever else. I mean, it support currently MySQL and file store from GCP, and the file store is just AWS S3 or GCP GCS, and I mean it's cloud provide managed service, so it's not you really have to be care about that. And one install is just a simple Redis instance, so it can up and down, but yeah, it's not affect your company's CI/CD platform, so you don't have to worry about that much. And if you are the developer of team, the thing you have to care about is even easier. You have to you just need to install that agent, and you prepare that pipeline aside with your manifest. Then that PipeCD will take the rest. Of course, you still have to do the development work. So the good point is you can focus on that. And also the agent, every management feature can be you can interact with the agent via the PipeCD UI. So you not actually have to all the time touching the cluster or something is not good. So we know that, and we make that as easy as clicking something on the UI. Okay, so next I want to talk a little bit about the security retrospective of the PipeCD. I just talked previously about why we should not use the CI to do the CD work or pipeline commonly for every CD task, because if you do that, your pipeline CI has the credential to access to your cluster, your production cluster, and as a CI/CD platform engineering team, which means that there would be someone else not from your team understand the credential, understand for say for instance, when you have centric Jenkins for the whole company wise, that Jenkins could get whatever credential to access to whatever cluster in your company, and it's quite single point of fail, or the point to attack if I'm the one who want to do something bad. So the PipeCD architecture we avoid that by making the agent running in cluster. Your agent will has the credential to actually touch the application in the cluster, and also it has the way to connecting to the Git, quick pulling the application manifest, and that all the control plane do not know anything about that cluster. Your credential is safe in your cluster, and that was the point, not leaking anywhere. Also, every request from the agent to the control plane is polling model. It's outbound request only, which means that the platform team who has maintaining the control planes do not need to know what and where your agent be installed. It's just the place of just place we storing the application state on deployment. That all. So it's way safer. Also, PipeCD have some security feature as well. We have a built-in secret management. Basically, this one is templating feature that support you. You can storing your things, password or credential beside with your manifest. And we have RBAC as well. I think it's fair enough for production ready things. Also for the SSO login things. Okay, so next one is progressive deliveries. As I said before, progressive deliveries is about how to automatically deploy the new version to subset of your user and then evaluate any problems, any correctness, any performance issue before running in to the old user to reduce the effects. If you actually do kind of B2B or B2C service, you can understand what I mean, especially B2B. They really care about the uptime, the non-code bug-free environments. So this is the thing that we should care about if we actually care about our user. And PipeCD have this state with names analyst state. Basically, this state will perform some kind of prompt chaos to the canary run out workload and actually testing something that you writing down. And if anything wrong happen, it's automatically trigger the rollback. And it's not only for Kubernetes, but the other as well. Oh, sorry, I missed a slide. Okay, so internally the analyst state basically is the PipeCD agent connect to some kind of metrics exporting service like Prometheus or Datadog, which currently be supported by PipeCD, and it's perform the prompt chaos queries, and we have kind of threshold or something like that. And if you find something wrong, then it's trigger the rollback. Okay, next one is the deployment change feature of PipeCD. We have here is kind of application finish, then trigger next application, then trigger next application deployments. Which I have here is a simple use case where we have Terraform like as an IAC for your cluster. Then after this one is updated, then you update, you trigger the deployment for your Kubernetes application or Cloud Run application at the same time, and then you trigger the update for the next application. Is everything run on chain? And another use case is we have developed environment application. We have to test this one first. Then if everything fine, then we go to deploy the staging environment, then go for the production environments. Or as our company's use case, we have multi-region application as well, service as well. So we can release to the Asia first, then US, then Europe. Is minimize the impact to the end user by grouping them by location. Okay, so next one is check for key feature of PipeCD. So if you know about the DORA, I mean the 4 keys feature to actually has some inspiration of your development process. You will understand what I mean. For here, we support 2 metrics for the inside to the application deployments, which is deployment frequencies and the chain fail rate. Okay, so there is a lot more feature of PipeCD. You can test by yourself. If you we have a live demo here, so you can access it and click around. Just need to log in using your GitHub account. Then you can clicking around and viewing things. One of the feature I want to talk right here is we can integrate. We are CD things and we are focusing only on CD, but we can integrate easily with any CI. You can just using your CI, and as the last step of your CI, you trigger the deployment by send an event to the control plane. Then the CD by PipeCD can perform the rest of the pipeline at the CD part. Okay, so a little bit say about PipeCD at my company. Currently, the PipeCD handle one centralized control planes can handle about 3,500 applications, and it's increased day by day, and it's working well. And a little bit more in details, that is 75% is Kubernetes workload, and about 25 for the other workload kinds. But yeah, it's pretty much work that that be done. And about the number of deployment, I cannot share the number here, but for one team, we have several of team, about several of 10 team already use PipeCD in our company, and it's combined to 3,500 applications in total. And for single teams, they said to me that using the insight feature, they know that they have about 300 deployment be triggered a day, and I think it's pretty much enough. And at this place, is your, we need you, where we are an open source project. We are have getting so far. We just we're not just getting that far. We just a state of introducing ourselves to the open communities. So we need your help. We are looking for the community adoption, which means that you can just try it in your free time, or you feel interest, you can just talking to your boss and let's try something new or something like that. And we are open source. We love contribution, issue discussion, PR, whatever, and start if you feel interest. And thank you. I leave the QR code here. You guys can